So this is the first lesson of Unit 6 for Algebra 1, Systems by Graphing. So in the previous section we looked at how to graph equations of lines like this, and what we're going to do this time is we're going to have two equations. We're going to graph both of these, and what we're actually looking for by solve is where do the two graphs actually intersect. So both of these graphs start in form y equals, so this is slope-intercept form. So the number of x's tells us our slope, and the number at the end tells us our y-intercept. And we're going to use this to help us actually graph this equation. So the -3 on the y-axis, -1, -2, -3, tells us what our starting point is when we come to draw this. Now for slope, we use rise over run. So if it's just a single number, write it over 1, because 2 divided by 1 is 2. But then now we have a fraction to do rise over run. So we're going to rise 2 squares and run 1 square. When you run, you must go to the right though. Repeat this a couple more times, up 2 across 1, up 2 across 1, up 2 across 1, just so we can clearly see what the pattern actually is for this. Then we go ahead and join them up. And that's our first graph, so that's y equals 2x minus 3. Now for our second equation, actually it also starts at -3. And I'm going to do this one in blue. X, now actually there's no number here at all, which means that it's 1x. And I need to make it into a fraction again, so we're going to do 1 over 1. So we rise 1, run 1, rise 1, run 1, rise 1, run 1. And keep doing this for the duration of the graph. And then we can go ahead and join this up as well. And when we join up this one, it looks like that. Now, when we're trying to solve, once again, what we're actually looking for is where do the two lines actually cross? So for this one here, you can see that it crosses at this point here. So the coordinates of this point are, well, you go 0 across, but then we go down 3 places. So that's actually our answer for this, 0, -3. As this is an x coordinate, we could write x equals 0, and we could write y equals -3. So a system of equations, two unknowns, normally x and y, and we have to find the value for both of them. Now this is a very special example for a couple of reasons. First of all, we've got the equation written in a slightly different form than we had in the other form. This is in standard form. So we could rearrange this into slope-intercept form, or we could just go ahead and graph this as normal. I'm actually going to go ahead and rearrange this equation to practice that skill. So 2x minus y equals -1. If I bring the 2x to the other side, then it becomes -2x. And if I divide everything by -1 to change the sign here, then I get y equals 2x plus 1. And the advantage of doing that is when we come to graph this now, we know that it starts at +1 on the raw y-axis, and the slope is 2 over 1, so up 2 over 1, up 2 over 1. And then when we come to draw our line, hopefully that should be slightly easier to draw. Now, same idea for this one, so I'm going to subtract 4x from both sides. So that cancels, and I get -2y equals -4x plus 6. And then divide everything by -2. So that cancels, and I get y equals -4 divided by -2 is +2, and 6 divided by -2 is -3. And then hopefully when I come to plot this one, we know the y-intercept, -3, so we can come down here. And slope of 2, so 2 over 1 again, so rise 2, run 1, rise 2, run 1. And we can go ahead and join those up as well. And remember what we're trying to find. We're trying to find where do these graphs actually cross. Actually, you can see from that picture that they don't. And in fact, actually for these lines, these are parallel lines, so these will actually never cross. So we can actually say for this question, no solution. These graphs will never cross, so we can't actually give a specific answer when they do cross. And I hit it from the start here, but a system of equations has no solution when the lines are parallel. Now there's a couple ways you can tell that. You can look at the picture, but you can also look at the equation as well. So from here, we saw that the question had a slope of 2, and also here it had a slope of 2 as well. So you can just look at the equation as well and come up with that conclusion. Now for my third and last example, we're going to do something slightly different again. So we'll have one in slope-intercept form, and we'll have one in standard form. So first of all, I need to rearrange the one that's in standard form so I can actually find out where it goes to the y-axis. So I could bring the x to the other side here. So if I subtract 2x from both sides, that's going to cancel. So I get negative 2x plus 4. And then if I divide everything by 2, then that's just going to give me what y equals. So negative 2 over 2 is negative x. 4 over 2 is 2. Now once I've done that though, look what happens. My second equation is actually the same as the first equation. So I'm not going to actually do an accurate sketch for this one, but negative x plus 2 is going to look something like this. It's going to have an intercept of 2, and it's going to have a negative slope. Now the problem becomes, when I try and graph the second line, obviously it's exactly the same line. So where do these two lines intersect? Well, here, 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 here. Actually, any single point on that line, in which there's an infinite number of points on that line. So when we end up with identical equations like this, then what we say is infinite number of solutions. So a couple of special cases to be aware of. If you have two lines that are parallel but not the same line, then no solutions. And if you have two lines that are identical, then we're going to use this infinite number of solutions. Most questions actually just simply have one answer where they cross. So that may be the ones that you should look out for the most. Now there is some vocabulary that goes with this as well. So system of equations, two or more linear equations. The solution is where the lines intersect. If there is at least one solution, and for our questions there's only going to be probably one at the most, then the graph is called consistent. If the graph has no solution, then it's called inconsistent. And if the graph has exactly one solution, which most of our questions should, then it's called independent. So there is a couple of bits of vocabulary that are associated with this chapter as well that you might want to choose to learn.